Hello viewers, welcome to this Tech Talk on Sisense AutoScale. My name is Durga Sethuraman and I'm a solutions architect at Sisense. Let's begin with Sisense AutoScale. The key takeaway from this presentation is to understand the capabilities offered by Sisense to enhance performance of the application and to cut costs when resources are not being utilized. If you have questions, please post them in the chat and I will answer them at the end of the presentation. This Tech Talk covers the auto-scaling feature offered by various aspects of Sisense, such as Node Autoscale, Microservices Autoscale, Database Autoscale, that is the Elastic Cube, Cloud Data Warehouse, MongoDB Autoscale, Storage. Node Autoscale. For the node autoscale, we are using the Kubernetes autoscaler that is configured on the system. Node groups have labels such as application, build, or query. For example, on EKS, they are set as node groups. We can do application and query together in one node group and build separately. Sometimes these are different node groups depending on really how much stability you want in the system. We define a reservation for memory and CPU of the pods. We also define the maximum. But the reservation is important. If there is a reservation and then the machine does not have enough resources, then it asks for additional node. So that's how pods are being added to the system, which in turn will trigger another node. And we also have the data group. In the data group, we can assign elastic cubes to a node or to a Kubernetes label. So when you set up the node group, you can define a different node group with a different label. Then in the data group, you can put the label of that node group of the elastic cube. In the node group, you can define such that when a build is done on this node, it will start a new node from the node group. Then when the build is done, the node is terminated after that. Customers that need need the very big machine for the build for specific cube implement this. By default, most of the services have two replicas. We added CADA to the system. CADA is the Kubernetes Event-Driven Autoscaler. CADA works alongside standard Kubernetes components like the horizontal pod autoscaler. We usually monitor the system by CPU. So when the CPU reaches, say, 50%, we start increasing the number of pods and scale them one by one. And we start to scale down only after 5 minutes of stability below the 50% threshold. The scaling down is done one pod at a time. The polling interval for monitoring is about 30 seconds. The default minimum for the number of pods is 2 and the maximum is 20. These settings can be overwritten and configured. We moved from the descheduler to topology spread constraint, which is a feature in Kubernetes. This feature balances the pods between different nodes. And the max queue is 1, meaning that it will allow difference of one pod between the nodes. Here we cover the elastic cube autoscale features or the and how to enhance the performance of elastic cubes. The Elastic Cube usage is monitored by management and query. In the data group, you can set a shutoff on idle, meaning that if the cube is not being used, then it would be automatically turned off after a specified time. We also added other capabilities in the data group. That is, it's not in the UI, but it's in the API that you can define new maximum number of instances. The way it works is this. We look at the queue of the query queue for the number of requests in the queue. If the number of requests is above a certain threshold, say there are 30 queries, then additional instances can be loaded on the Elastic Cubes. Also, we have a feature for cold standby for Elastic Cube. So you can define Elastic Cube and a cold standby Elastic Cube. If you want to load balance this cube in another node, and only when the first one dies, the second one will start. That is interesting if you want to have cubes in S3 and the big cubes take time to load. Maybe you want to download them, open them, but not really use both of them at the same time. The cloud data warehouse. We usually use this when the warehouse is configured with AutoScale. We take advantage of the AutoScaling features in the data warehouse. Snowflake and Redshift offer AutoScaling capabilities. We do B2D, also known as build to destination in Sisense, with separate query and build data warehouses. The build consumes less resources, however, query consumes more resources. So when the query usage is high, the cloud data warehouse takes care of the autoscale. In MongoDB, we have started supporting Atlas. You can configure the connection string in the values.yaml file during installation. Atlas supports autoscale. If you go with Sisense, local Mongo, you can adjust the CPU and memory. They are configurable. With the Atlas Autoscale, it takes time under load. However, there's no downtime. Storage. We recommend to use S3 storage for large cubes. The Elastic Cube tar.gz file is copied to S3, and S3 is capable of high traffic, and the tar.gz is much smaller than the cube itself. You need to define the S3 retention policy. When the Elastic Cube is started, the data is downloaded from S3 to the local storage. We typically use local disk MVNE storage, which is part of all the R6D machine, and that's the fastest storage that we can get. And in case the machines have multiple and ephemeral storage, say if you take big machines, they usually have more than one storage. In such case, we mount them together with the load share, doing an interleave between different sectors of the disk. So that also increases the speed. We also have the documentation on how to do that and a script that helps doing that. So from S3, we download the tar.gz, open it locally. And when you are doing the build, the query cube is defined as active only after we download and open the cube. The whole flow is part of the build.